8.77. Here we're making aspirin from salicylic acid and acetic anhydride. We did this example relating to this reaction before. So if you look closely at the reaction in the textbook, you can see it's balanced. So instead of writing all the formulas out, I'm just going to use a little shorthand. So the 1 salicylic acid plus 1 acetic anhydride produces 1 aspirin and 1 acetic acid. So I'll just call that V for vinegar. So the question says, how much salicylic acid is required to produce 0.4 grams of aspirin, which is about the content in 1 tablet? Assuming the acetic anhydride is present in excess. That's nice to know, because now we only have to do one calculation. If I know I have excess of that, that means I've got plenty of it around. It's not going to limit how much product I can make. So the amount of product I can make is limited by the amount of my salicylic acid. That's limited. So if I have a certain amount of that, which the amount I have is, well, I'm looking for that. That's what I want to calculate. How much of that do I need to make 0.4 grams of aspirin? So how many grams of salicylic acid do I need to make 0.4 grams of aspirin? So if I have information about one substance, I want information about a different substance, I first have to cancel the grams and go to moles. Because I only know the mole relationship. I don't have any other relationship to relate one substance to another from working with a reaction. So this relationship for aspirin is going to depend on the formula for aspirin. So that's C9H8O4. So 9 carbons, 8 hydrogens, 4 oxygens. Gives me 180.15 grams per mole. Then I know I can cancel moles of one substance and get moles of a different substance using the ratios in the balanced reaction. Then if I want to convert the moles of that into grams, I need the molar mass of that substance. So the salicylic acid is C7H6O3, so 7 carbons plus 6 hydrogens plus 3 oxygens is 138.12 grams per mole. So all my units here are canceling except the units I want. So I have 0.4 divided by 180.15 times the 138.12. Get 0.307. So if I put 0.307 grams of salicylic acid in this reaction with excess acetic anhydride and all of the salicylic reacted, I could get up to 0.4 grams of aspirin maximum. Part B, calculate the amount of salicylic acid needed if only 74.9% was converted to aspirin. Right, so what we just calculated here was assuming a 100% of the salicylic acid is converted to aspirin. But if the actual reaction doesn't give me 100% yield, I won't be able to make that 0.4 grams of aspirin that I was shooting for in my calculation. So if I know that the percent yield is going to be less than 100, I need to shoot for more aspirin. I need to put more salicylic acid in, knowing that only a fraction of it is going to react. So how do I do that calculation? What should I do? Yeah, I could do it that way. That would be an effective way to do it. So if I'm assuming that the mole ratio is 1:1, or that for every 1 salicylic acid I get 1 aspirin, but I realize that I'm not going to get 1 for every 1 because it's not 100% yield. In reality, it maybe is only 74.9% yield. So that would mean for every 100 reactions, only 74.9 of them actually give me product. So if I started with 100 of these, I only get 74.9%, or I get per 100, so I get 79. What did I say? 74.9 of the product. Right. So that's technically not chemically correct, because in reality what's happening is every one of these that actually reacts does give me a product. That's what the balance reaction tells me. What's happening here, if I only get a 74.9% yield, is that only 74.9% of these actually react. So the ones that do react all give me product, but the ones that don't react don't give me product. So they're just sitting there. For some reason, they're not reacting fully. But if I think about it this way mathematically, it makes sense. So that's probably the easiest way to do it. It's easier than the way that I was initially thinking. So let's approach it that way. So if I were to have a different ratio there, because only some of my reactants going to react, I could use that to do another calculation. So I could say, how many grams of the reactant do I need to make 0.4 grams of aspirin? So I guess we can do this both ways and see whatever way you think makes sense more to you. So in this setup, if I'm assuming that if I'm account for that discrepancy in the percent yield based on adjusting the mole ratio, everything else would be the same. So I could first convert to moles. And then as a percentage, I can say I'll only get 74.9 moles of aspirin for every 100 moles of salicylic acid I start with. Because I'm not getting the 1-to-1 ratio the reaction predicts for some reason. I'm only getting 74.9% of that. And then the last step would be the same. So technically, this relationship is not equal. But I recognize that in this specific case, if the percent yield is limiting me, I'm not going to be able to get the 1-to-1 reaction that I expect. So that legitimizes that approach. So if I were to do it that way, and plug everything in, that means I would need 0.409 grams of salicylic acid. So as we said, I need to boost up the starting amount if only 74.9% of it is reacting to give me the 0.4 grams of aspirin I need. Another way to approach that would be to say, I can use, if they're giving me the percent yield, I can use that in the percent yield formula. If they're telling me the percent yield is 74.9%, and that's equal to the actual yield, which I know I want to actually make 0.400 grams of aspirin, what's the new theoretical yield? I could solve for the new theoretical yield. So theoretically, how much product do I need to shoot for if I know that the percent yield is not going to be 100? Right? So we did an example just like that a minute ago, but if I plug that in and solve for the theoretical yield, that'd be 0.4 times 100 divided by 74.9. So that ends up being 0.534. So that means instead of shooting for 0.4 grams, I could just do the calculation and shoot for 0.534 grams. So if I set that up, how many grams of salicylic acid would I need to get 0.534 grams of aspirin? Then I would do the calculation the same way we did in the first part, 180.15 grams of aspirin for every mole of aspirin. Then the balanced reaction is 1 mole of aspirin producing requiring 1 mole of salicylic acid, and then 1 mole of salicylic acid for every 138.12 grams of salicylic acid. That will give me 0.409 grams of salicylic acid. Right? So either of these two approaches give me to the correct answer. So I can say, well, the mole ratio should be 1 to 1, but if it's not reacting 100%, I can adjust the mole ratio and figure out how much salicylic acid I would need with that lower percent yield. Or I can plug in the percent yield and figure out, theoretically, how much product do I really need to shoot for if it were a 1 to 1 ratio, if that percent yield is going to be lower. And so I could do that as well. Either way, I need 0.409 grams of salicylic acid to produce 0.4 grams of aspirin if the percent yield is only 74.9%. Questions about that? Then in part C, I'll just do part C here. Same reaction. Get rid of this part B stuff. In part C, it says, in one experiment, 9.26 grams of salicylic acid react with 8.54 grams of acetic anhydride. So here, instead of saying how much product we want to make, they're giving us in part C amounts, 9.26 grams of a salicylic acid and 8.54 grams of acetic anhydride. Calculate how much aspirin we could make. What's the theoretical yield? So this is a more traditional type of approach here. If I have amounts of each reactant, for how many of our reactants there are, I need a separate calculation to calculate how much product I can make from that reaction, from that reactant. So I could figure out which reactant is limiting. So I would start by saying how many grams of aspirin could I make from the 9.26 grams of salicylic acid? How many grams of aspirin could I make from the 8.54 grams of acetic anhydride? So to save a little time, I'm going to take a couple shortcuts here, but we've done a lot of these so far. So to go from grams of salicylic acid to moles of salicylic acid, that's the molar mass. Right, so I'll get the molar mass of salicylic acid. We already did that in the previous part. Plug that in there. Then I would use the balanced reaction to convert moles of salicylic acid to moles of aspirin. Then I would use the molar mass of aspirin to cancel the moles and get to grams. So that will give me grams of aspirin. Then I would do the same thing for the acetic anhydride. I would use the molar mass of acetic anhydride in grams of acetic anhydride per mole of acetic anhydride. Then I would use that ratio in the balanced reaction, which also happens to be 1 to 1, to convert to aspirin. And then this step here, I would just duplicate down here. Grams of aspirin per 1 mole of aspirin. That would give me a different number. Or maybe it gives me the same number. Either way, I choose the lower of these two numbers as my theoretical. the lower of those two values, that's my theoretical yield. So that would be what they're asking for in part C. And then they also ask for the percent yield if 10.9 grams is produced. So the percent yield is going to be the actual 10.9 grams produced divided by whichever of these two is lower, the theoretical grams times 100, and that will give me my percent yield.